that hat off inside, please, sir. Have y'all been in classes with these goofballs forever? You're a junior. Give me questions about your homework. 9? 9? All right, number 9, make sure you are checking your work as we go. What's the biggest perfect square I can take out of 72? 36 and what? 2? I choose 36 because that's the biggest. If you chose 9 and 8, that would be fine, but you'd have to break 8 down again, right? All right, so the 5 stays out here, so I've got 5 times the square root of 36 times the square root of 2. Oh, on the back? Oh, well, I got to finish this now because I already started it. Okay. 9 on the back. 9 on the back. Ooh, that's a good one. This square root of 36 is 6. All right, other 9. Negative 1/2. X squared plus 1 equals negative 39. I only see x written one time, so what should I do? I should sad map my way out of it, right? Subtract the 1. Now I have negative 1/2 x squared equals negative 40. What happens now? Multiply by negative 2, right? I'm going to flip it over. Yes? Everybody okay there? You were wrong? No, I'm not. You're wrong. All right, I got x squared equals, now this is positive 80, right? How do I get rid of the squared? Square root. And now I need to see if I can break it up. 16 and 5. What's the square root of 16? So plus or minus, don't forget the plus or minus, right, Will? Plus or minus 4 root 5. That gives me my 2 what graphically? X what? Intercepts. That's exactly right, yeah. Well, but you would have had a negative under the radical, and you can't take the square root of a negative number. Not yet, anyway. All right. Up here, up here, up here. Will. What else from your homework? That was easy? Let me do an experiment then. A quiz on this? No. Do this on your paper, quickly, quietly. I want you to do this one on your own. Everybody do it on your paper right now. Grayson. What's the first step? And then we got stuff. All right, and then I multiply it by the reciprocal. That's exactly right, which is 3 on both sides. So I get x plus 2 squared equals 21. All right, so square root. Now I'm going to stop here for just a second because can I break that down?
No, you just meant x plus 2.
So I got x plus 2 equals plus or minus square root of 21, right? Got to get those 2 values there. And then I subtract 2. Now, I'm going to write this a little differently than what we did yesterday. I'm going to put the 2 in front instead of on the end. It doesn't matter. It just looks a little bit prettier, especially when that number is a negative. But I can't combine those because it's not under a radical. Just make sure your plus or minus is in the right place. All right, how are we feeling about we'll still be practicing with this as we do imaginary numbers. All right. Imaginary numbers.
I got one right here. Yeah, 147.
I can't imagine why, Jamar.
Yeah, I got it. 127 minus 5 million. Quarter million. 276.7.
And you have literally walked in circles around that table.
I need one.
Woo, let's take advantage of the fight a second. All right, imaginary numbers. We talked about yesterday, with radicals, something can't happen. What is it that can't happen with radicals? They can't be where? In the denominator, right? They can't be in the bottom of the fraction. And there's one other thing that can't happen with radicals. What is it? The negative inside the radical. I can't have a negative under there, right? It doesn't make sense. If I do this, there's not two numbers that multiply to -4 if they're the same thing. Because if they're both positive, you get a positive. If they're negative, you get a positive. Yes? Does that make sense? Okay, so all right. All right, here we go. If there's a negative under the radical, we are going to use an imaginary number to take the place. I am going to say that the letter I represents the square root of -1. And if I let I be the square root of -1, then knowing what I know about how I can split these radicals up, I can make this the square root of -1 times the square root of 4. And I know that the square root of -1, I can put an I. And what's the square root of 4? 2. And so I could get 2I here. Okay, but I pulled the negative out. I pulled the negative out. And whenever I give you the very first concept.
Can we just do normal notes?
So I'm not, all right, look, this is. So I take it this is something that you do not know from Algebra 1 and has not been taught before. This is an Algebra 2 standard, so you may not. All right. Let me explain this again, so listen carefully, all right? If I have a negative, under the radical, right? If I say that I is the same thing as the square root of -1, and in math, that is it's kind of like pi is 3.14. I is always, little cursive, not cursive, little italic I is always the square root of -1. If I know that, then I can split up -4 as -1 times 4. Because I don't know how to take the square root of a negative number. But if I take that negative out, and I replace the negative with the I can take the square root of 4. Okay? So the takeaway here is if you have a negative under the radical, drop it 'Cause- no. What, I already started over. Y'all keep saying, well, you start over. I've already started over twice. Square root of -1. Ever. Because we work, it's a different number system. Like you have real numbers, you have whole numbers, you have integers, you have rationals, you have irrationals, you have imaginaries. It's a whole new number system. If there's a negative under the radical, drop it off and replace it with an I outside the radical. Absolutely. Y'all don't make this harder than it is.
Negative is an imaginary number. He's laughing like it's small.
I know that is hard. Grayson said, I'm going to come over here and do it. If it's negative 27, and I need to simplify that, first thing I'm going to do is drop the negative and put an I out there. And then I am just going to proceed like normal. Okay? I'm going to continue. So this one, you might notice, can break down in 9 and 3, right? So square root of 9 is 3, so this becomes 3i root 3, and then I put the plus or minus out front.
Why you put the I behind that?
So in general, an I is going to go in front of the radical or behind a whole number. So if it's negative 4 under the radical, that's I times the square root of 4. What's the square root of 4? 2. 2 times I.
The I is always the closest to the.
Yes.
Why would they do that? That looks like that.
Y'all let me know when y'all are done. Boys and girls, pay attention. All right, so the very first thing, I'd do that first too. I would just take that negative out so I didn't have to worry about it, and I would put it outside. So we got 3i, 5, 7, 8, and 2. What can I do now? I could do 5, 7, 8. We'll do 5, 7, 8 first then. What's the perfect square? This was actually on your homework last night. 289 and 2? I could if I already did it for homework last night. What's the square root of 289? 17. 17. Hot July moon. So y'all don't know that song? You know it, Grayson? So next time sing it with me. Now what? What's 17 times 3? 51. I can combine these two, yes. Ooh, look how nice. $17 times 3. That's half the answer. The negative. I didn't say half the work, I said half the answer. All right. If that was all it was, oh my gosh, Will. All right. If that was all there were, then we'd be smooth sailing. But unfortunately for you all, that's not all there is. So let's talk just a second about some iterations of I. Yeah. Band-Aid? Oh. All right. You done, Grayson? Other Grayson. Now, an iteration is whenever a pattern occurs and it starts repeating itself, okay? So we're going to talk about some iterations of I and what happens. Now, I know that I equals what? No, square root of -1. So what do you think I squared would equal? Somebody said it. It's -1. Here is why. If I square this, these are inverse operations, right? And they cancel, right? So I just get -1. What if, and these are very important, you'll want to highlight these or something, the whole iteration list. I to the third. You're exactly right. If I multiply these two together, I get -1 times the square root of -1, which I call negative I. So I cubed is negative I. You see why? Oh, you do. Where do I use this in the worksheet? Wait, so Alex, do we need to Some of us will never use it again. It's negative square root of -1. I to the third, if I do I squared and I do another one, that's I to the third, right? Think about your exponent properties. So if you multiply these two together, I -1 is negative I. You're exactly right. So that means, Will, I to the fourth, negative -1, which is positive 1. What? I's always under the rock. Multiplying, not adding. All right, stay with me. I to the fifth would be negative. What's I to the fifth? The square root of, all right, watch, look. Somebody's going to pick this up in just a minute. I to the fifth would be the square root of -1, which is just I. What about I to the sixth? -1. What's happening? Negative. How many iterations of I are there? 4. Oh, yeah. After 4, they start repeating themselves. right? So, right. So this would be, so I to the 5th, I to the 6th, I to the 7th, and I to the 8th would be these values. And then it would start over. Then also I to the 9th, I to the 10th. Knowing what you know, shh. Waterfall.
What is waterfall? What is waterfall? Because I know what waterfall is. What are you saying? Waterfall. What is waterfall?
Flat tire.
I don't know. What is take the mic, put your thumb okay.
Her mom teaches elementary school. How do you not know these things?
What is a waterfall? My God.
All right.
Quiet owl. You got quiet folk, quiet fox. Oh, no.
Okay, back to my eyes. They start repeating after 4. Okay, so you have to know these 4, but they're easy to derive like we did. Now the question is, how are we going to use this with other power towers that's handy? Well, what if I asked you, what is I to the 23rd? What is it going with? Which one is it? So I could go 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. But what's a better way? Because what if it was 123? What's a better way that I can do it? Yep, that's exactly right. So y'all are all getting there, right? If I take this and I divide it by 4, okay? If it goes in evenly, that's easy, right? If it goes in evenly, I'm down at this last iteration, right? So this one has no remainder. It goes in even, okay? It doesn't, though. What's my remainder here? 23 divided by 4 would go in 5 times with a remainder of 3, right? 0.75, right? That's my decimal. So my remainder of 3, well, which iteration would that go into? 3, right? The third one, because it's right. Or when you divide it, you get 0.75. Remainder, that's just a remainder of 2 or 0.5. So the iteration is telling you what the remainder is going to be if you divide by 4. I'm trying my best. Okay, so look, I to the 23rd is going to equal what? So it's negative I, 1, negative 1, or just I. That's what I'm going to use. So circle those so you know. That's what you're going to use for
So why for 3 didn't write that thing before? Why for 3? I thought the number 1 to the I equals the square root of -1. Then that means that you wrote it further than 3 and to the left of the -5. I can write that.
I was showing you why.
Why from the first example, uncircle I?
Because we wouldn't replace it with square root of -1. If you ever see, like, if it ends up, if I had, like, I don't know, I to the 5th, we would say that's the same thing as I.
I to the 4th, they got 1.
All right, so look, write this down. This is the part that goes with it. It's going to help you remember.
It's like a quarter.
It is like a quarter.
Yeah.
Yeah. Because if 4 quarters make $1.
Like a quarter. Oh, yeah. Whatever's left, that's how you.
That's exactly right. That tells you how many. So if it's a remainder of 2, that says go to the second iteration. If it's a remainder of 3, that says go to the third iteration. Sure. Okay. It's the iteration number. So remainder 1 would be the very first, the I to the first power. Remainder 2 would be I to the second power. All right. Stay with me. What is? Will, this one's for you. Ready? Okay. What is I to the 235th? Wait, Grayson, I got one for you. Grayson. Wait. This is Grayson's. I to the 1738. Yes. All right. Everybody's asking me. I haven't divided them. 235 divided by 4 gives you what?
No, it's 0.75.
Like, what you say it was? So 0.75, that's the part I'm looking for, right? The 0.75. 0.75 is a remainder of 3. That's the third iteration, so that means this equals -I.
Alright, pretty easy. Well, you just
Help me. You want to be the teacher. Tell him. Explain it.
You just get that number right there and divide it by 4. And then whatever the decimal is, so it's 0.75, it's a quarter, 1 quarter, 2 quarters, 3 quarter, 4 quarter. And so it's 3. No, it's point. No. What's the other one? This one? What is? 17, no, it's 2. How do you get -1? Wait, I thought you just did it. This is the answer.
What does it equal? All right, explain it. So
1738 is equal to 434.5, which is I2, which is -1. What can I say?
That's not work. That's what we don't get. I want stuff like that. That's it.
Looks like a Thanksgiving turkey. Yes, you do.
Do that. Yeah, do that.
I'm just multiplying, right? Everybody agree I'm just multiplying? 2i to the 5th is the same thing as what? 2, 4, 8, 16, 32 I to the 5th. Do we agree?
Well, you are. I wasn't paying attention.
What does an exponent mean? How many times I multiply it, right? So this is 5 times, this is twice. So 2 times 2 times 2 times 2 times 2, 32. How many i's do I have? 7. What's the square root of 6 times the square root of 6? Which is 'Is it? I don't know. Is it? Tell me. And what is I3? Negative I. So this is negative I. So I have 32 times negative I, and it's times, not subtract, so be careful, times 6. What's 6 times 32?
192.
There's 7 of them all together.
2 days on this.
This is actually a quarter of the lesson. Remember, what's this whole unit about? What about quadratics? Solving quadratics. We haven't solved the quadratic yet.
Let me. Okay, can we just like stop right here? Let's not do it anymore.
Wait, no, using my, we have to do this. Hold on. Everybody does it over there. That's what we said. Yes. Yeah. Well, everybody do it on your own first.
You gotta write it on here. Though.
Oh, I don't want to do it.
I'll write what you say.
Okay.
You can do the talking. I didn't expect all this, y'all. All right, Grayson, talk us through it.
Okay, well, 125,
Where's that coming from?
the 5. Are you questioning me on the
No,
thing?
I'm not questioning you at all. I just know what they're fixing to ask.
What are y'all gonna ask? How do you get it? You get it by 5I3. You write 5I 3 times.
That's what I was getting at. Okay.
And then it would be 5 times 5 times 5. And 5 times 5 is 25. 5 times 5 is 125. Yeah. Okay. And then that would be 6. I'm at 9. That's 9. And then it simplifies to 3. And then let's see, that's 375. 365. 125. 375. 5. Huh? Oh, 5. Which is 2. Wait, which is 1, I mean. No. Yeah, right? Right?
1.
Yes, 1.
Which is what?
1. Oh, negative I. Square root. Oh. Wait. I swear one I was square root thing.
Solve it for x.
Okay, so you're gonna add the 3.
This is just
Everybody
what we did
do it
before.
first, then we're gonna explain it.
I
Okay.
think we have found what you're good at that keeps you from being a distraction.
What am I good at?
Explaining the problem. Yeah.
Well, actually, that might work.
I hope you have a classroom full of Graysons and Carters if you teach.
I don't know what Carter is like.
You don't even need a classroom full. Just one in each class is enough. All right.
Everybody raise your hand when you're done.
You want us just to keep our hands up if we're done?
No.
Oh.
You put your hand down.
What do we do when we're done?
Then, when you're done, you raise your hand so I know who all is done.
Keep it up.
You don't have to keep it up because your arm will get tired.
So what do we do now if we're done?
So now I will ask you in about a minute who all is done.
Give the answers, Ocean.
Yeah, guess right now. X equals 11. Well, let's see.
I don't know. I
yet.
haven't worked it yet.
Okay, everybody raise your hand. Who's done? Raise your hand if you're done.
I think we just need to do it.
Okay. So you start off by adding the 3.
You should really ask for them to tell you how to, like, call on
Class,
people.
tell me
Call
how
on
to do
people.
it. So yes, you add the 3. Yes. And then you have to wait. Why don't you do the thing?
Oh, somebody tell him. Why don't you do the thing first? Gotta get x by itself, but why don't you do the radical before you do the dividing? Backwards, 10 dots. That's exactly right. Exponents are
Okay.
gonna be left.
484 divided by 4 is 121. Then you do it. And then it is, isn't that 11 times 11? 12 times 11? Wait. No, yeah, 11 times 11. Right? Yeah.
Close though, that's half the answer.
Plus or minus right there.
One more question and then I'm gonna set you loose on your homework, yeah. Because it was, go ahead. Oh, it was negative under the radical. Right. We didn't have any negative under the radical. Same thing, but there weren't negatives under the radical. Listen to this question carefully. Let's see if you can get this. When we saw the quadratic for x this way, what are we finding?
Finding the I.
The x-intercepts. How is it imaginary? What does this look like on a graph? Which would look like what?
Yeah.
You are. I owe you a piece of candy. Just wait. Right. If they're imaginary solutions, we're not graphing imaginary numbers. We're graphing real numbers. That's why. So they're not on there. So see how everything's connecting back? It all comes back around.
It all comes back to what she has been teaching.